Alrighty, folks. So I'm going to give you guys the recorded version of the lecture from today, September 2nd. Here are all the things that we're covering to get ready for the quiz on Friday, September the 4th. Graphing, variables, Bunsen burner, standard apparatus, and the Milk Lab. If you're watching this, you probably haven't watched the Milk Lab yet, but that's in the Thursday folder. Got some really awesome bloopers, by the way. But there will be a question or two about the Milk Lab on your quiz. And please don't forget to get your participation points. Remember, go into that Thursday folder. If you're watching this recording, you probably weren't in live class today. So that means you want to put answer B, saying that you came to office hours, because you need to come to office hours to see me in person on Thursday if you missed class in person on Wednesday. All right, so I'm going to fly through these. So this is the type of video that you probably want to pause here and there every time I ask a question to make sure that you could answer it without just watching the answers come up in the video. So the first thing we did was we labeled the different parts of the standard apparatus. So arrow 1, which is kind of pointing to this whole entire setup here, that is the ring stand itself, the pole and the big base right there. Arrow 2 is pointing to the Bunsen burner. Arrow 3 is pointing to a small ring clamp. What's sitting on top of that small ring clamp is our wire gauze used for even heating. Above that, we see the large ring clamp. You'll notice that this large ring clamp goes about halfway up this container here. You'll see me explain that in a little bit more detail in the Milk Lab. And then the 6 is our beaker, which is great for holding reactions, but not great for measuring. And don't forget, the top of the Bunsen burner to the small ring clamp should be a distance of about 3 fingers. So right there. All right, so then we did a little graphing practice. Here we have the heart rate of individuals in beats per minute versus the time they spent exercising in minutes. So what is the independent variable? Well, the independent variable is what we are testing. It should always be on the x-axis. In this case, that would be the time spent exercising. So we got that right there. Boom. What kind of relationship do these two have? Well, as time spent exercising goes up, we see that heart rate also goes up. So these two go up together. So that means they must have a direct relationship. Predict the heart rate at 70 minutes. So what would be a reasonable guess? We don't know for sure because we didn't get any data for 70 minutes of exercising. But we sort of follow this line, like, okay, if we just kind of kept going to 70 minutes here, it'd probably end up being something that's a little over 200 beats per minute. So what you guess, as long as it's like just a little over 200, so somewhere between like 200 and 225 is probably a pretty reasonable guess in my opinion. I exercised for like 30 minutes yesterday and my heart rate was like at 200 and I thought I was going to die. Good times. Anyways, so then we read through these scenarios and looked at the different variables. So one tank of goldfish is fed the normal 5 grams of food once a day. A second tank is fed 5 grams twice a day, and a third tank is fed 5 grams 4 times a day during a 6-week study. The fish's weight is recorded daily. So the independent variable, what are we choosing? What are we changing before the experiment even starts? Well, that would definitely be the amount of food that fish are receiving. We're trying to test, okay, if I give some fish 5 grams, some 10 grams, some 20 grams, how is that going to impact what we're observing or measuring? So that's why amount of food is our independent variable. We're observing it or measuring the weight of the fish. In our control group, the key word to look for here is the normal, okay? Remember, the control is considered the norm. It's used for comparison. And in this case, fish are normally fed 5 grams of food a day. So that's going to be our control. That's the group where if we never did this experiment, nothing would change for them. Next up, 6 redwood trees are kept at different humidity levels of 0, 20, 40, all the way up to 100% inside a greenhouse for 12 weeks. The height of each tree is measured once a week. Okay, so what's our independent variable? What are we testing to see its impact? That is going to be the percent humidity. We have chosen that, and we want to see what that does. What depends on the percent humidity? Well, that's going to be the height of the tree, which is what we're observing or measuring. And what's our control group? Well, we don't really know what the normal amount of humidity is for these trees. Humidity levels can change across the United States. So we're forced to assume, like, okay, let's just assume that 0% is them doing nothing. That's their control that they're going to compare back to. So trees at 0% humidity is going to be the control in this particular scenario. Back to another graph. So we're playing a little true or false. So we have 7 days of the week and the price per gallon of gas over those 7 days. So true or false, the price and day have a direct relationship, so they both go up together the entire time. Well, as day goes up, gas prices go up at first, but then they start to go back down. And so they're not going up together the whole time. So that would definitely be false. So I'm going to put a little F there. So the next one says price and day have an indirect relationship. So some people might think, well, if it's not direct, it must be indirect. Well, again, indirect means they're doing the opposite the whole time. So we see that, yeah, okay, from days 3, 4, and 5, as day goes up, gas price does go down. But from days 5 and 6, as day goes up, gas price just stays the same. So that's not really indirect. And also from days 1 to 3, as day goes up, gas price also goes up with it. So it's not really indirect either. So it's kind of neither. They have a direct relationship sometimes, an indirect relationship sometimes, kind of not really much of a relationship from days 5 to 6. So we can't say they have a direct or indirect relationship. It's pretty unclear. Is this a good description overall? Gas prices raised, lowered, and then leveled out? Well, we see them raise for a couple days, then we see them lower, and then we see them level out. The last 3 days in a row were all $1.36 per gallon. So yeah, I guess that's true. That is pretty accurate. And lastly, the gas price will definitely be $1.36 on day 8. So this is the day that we never plotted. So they're saying, hey, it'll definitely be $1.36, this point right here. So I'm looking at this, I'm like, okay, well, if I had to bet $100, I would guess that it's going to be $1.36 on day 8 because it was $1.36 3 days in a row leading up to that. But I don't know that. So the gas price will definitely be $1.36 on day 8? That's not true. Now, if you were to come in here and say the gas price will probably be $1.36 on day 8, you could maybe argue that that one is true, depending on how you want to go about it. The point is, I just want to emphasize, we don't know that for sure. We can't say definitely because we didn't get that data. So we have to be careful about what kind of conclusions we make. Back to Bunsen burners. Where do I control the oxygen flow? Well, if you remember this long tube, the oxygen flow controller, remember it has this little windows down here, so we let oxygen from the room into the Bunsen burner. So that's where we can control oxygen flow. What about gas flow? Well, that is controlled by this little gear down here. Remember, righty-tighty, lefty-loosey. If you tighten the gear, you're letting less gas in. If you loosen it up, you're letting more gas in. By the way, when I say gas, what gas were we even talking about? What gas do we use in this class? That would be methane, formula CH4. Okay, the independent variable is what you are blank during a lab. Well, that is what you were testing. So remember, that's the one you choose, the one you're trying to see what kind of impact it makes on its surroundings, so you're testing that independent variable. The dependent variable depends on the independent, and so that's what you're observing or measuring. You have no idea how that one's going to change during the experiment until you actually do it. And the control is often referred to as the norm, the normal, and is used for comparison purposes. And then lastly, a little review on our flames. So a birthday candle flame, you would recognize that because it is bright orange. Compared to other flames, it is not that hot. Now remember, it's really hot compared to that little paw of yours, but compared to other flames, it's not that hot. And to fix a birthday candle flame, you need more oxygen. So you got to open up those windows on the oxygen flow controller, the tube on the Bunsen burner. Big Blue is plot twist, blue in color, and is definitely hotter than a birthday candle flame, but we can do better. It's closer to that perfect ratio, and that's why it is hotter than the birthday candle flame, but it's not perfect. And finally, the perfect flame is incredibly hot compared to the other two. And that's because we've got that perfect ratio of 1 part methane, 2 parts oxygen gas. That's kind of what we're emphasizing up here. So this equation, so CH4 is methane, O2 is oxygen gas. We're trying to tell you, hey, you have 1 piece of methane for 2 pieces of oxygen gas. That's that perfect ratio. That's what we're looking for. And one thing I want to point out is remember that perfect flame, the inner blue cone must be 3 fingers tall. So that's this guy right here, the inner blue cone. You're like, what's the deal with the 3 fingers tall thing? What is going on there? Well, I want you to think about this. So we're saying that this has to be 3 fingers tall. Let's go back to the standard apparatus. Why is that? Well, if you think about it, so if I were to draw that inner blue cone here, okay, if that's 3 fingers tall and this distance is 3 fingers tall, that means the tip of that inner blue flame is going to be right at the bottom of whatever it is we're heating. And why do we want the tip of that inner blue flame to be right at the bottom? That's because zone B is by far the hottest part of that flame. So in other words, we're heating as effectively as possible when we have the tip of that inner blue flame right at the bottom of that beaker or whatever it is we're heating. So that's your review. Make sure you watch that Milk Lab and to get yourself ready for that quiz tomorrow. Good luck, nerds.